In this video, we'll do a short review for our test one, right? Let's see what topics will be covered in the first test. So for sure, limits and also how to evaluate limit will be covered. And continuity, a function is continuous, will be covered. What's the meaning of that, and how do you use it to solve some problem, right? And also the intermediate value theorem, one of the foundational results in calculus, intermediate value theorem, right? And I'll just give you a picture, say what's the meaning of that. You have a continuous function, so that's a good property of a function, right? You have a and b here. You have this is f of a, this is f of b here. So you have a continuous function, very good function, right? So this is f of a, f of b. And so if function is continuous, now what's the meaning of that is, right, the limit of the function value equal to the function value at the point, right? So if that happens, then there, okay, for any, right, for any number between f and fa and fb, for any n here between fa and f of b, right? Then there is a c inside ab such that f of c equal to n, right? No matter which point you choose, you can always get a c. This is our n here, such that f of c equal to n. So that's the intermediate value theorem. Other topics include including derivatives. For sure, we know the derivative is the tangent line slope, right? You need to get the tangent line equation and the normal line equation because they are perpendicular to each other, right? And also for a function, you sometimes you wonder what's the domain of the function. Domain is very important. Domain of functions. And lastly, right, very importantly, one of the big topic is the rules to evaluate derivatives, right? The rules including the following: product rule, quotient rule, and also chain rule. And also what's that called? Implicit differentiation. Differentiation. And lastly, we have logarithmic differentiation. So text one will cover everything up to 3.6 with 3.6 included, right? Up to 3-point section, 3.6, and this is included. So this section is included. So everything to 3.6 with 3.6 included. So what we want to do next is do a few examples and in these topics. So the example I will discuss do not cover all the topics. If you want to prepare for the test better, you should go to the homework assignment and do the problems in these topics, right? Then you will be better prepared that way, right? So that's the way to prepare for the test one. So that's the topics, and you just need to do all the problems in the homework, which is which in the assignment, which is related to one of these kind of topics. Okay, now let's do our example here. So let's start from the first example. Try to evaluate limit, right? Examples. First one is we are looking for the limit of a quotient as t goes to -2, t squared minus 4 over t squared plus 3t plus 2, right? Now you can see that this function, if you plug in -2, you get 0 over 0, right? This is an indeterminate type, which is 0 over 0, right? You want to cancel the zero factors, then plug in -2, right? So what you want to do is which factor make our denominator equal to 0, t plus 2, right? Happens that the denominator can be factored as t plus 1 times t plus 2. The numerator is t minus 2, then t plus 2. So this our zero factor can be canceled from the numerator, right? Everything will be canceled, or both zero factor will be canceled. Now this is same as t goes to -2, t minus 2, t plus 1, right? We know that for rational function, the function is always continuous as long as the number is in the domain. The domain of this function is everything, but the domain of the red function is everything but -2. So we can plug in -2 because the function is continuous at -2. So this is -2 minus 2 over -2 plus 1. So this is equal to 4, right? So that's a limit of such a function. Now let's see another example which require different techniques. We are looking for the limit of this function as x goes to 0. Square root of 16 plus x minus 4 over x. I want to know what's the limit of this function. Now you can see that if you plug in 0, again, you have 0 over 0. Somehow you want to cancel the zero factor. The zero factor here is x because that's a factor make our denominator to be 0. So we want to cancel that. One way to do that is we just multiply by the conjugate. As t goes to 0 to get rid of the square root on the numerator. So square root of 16 plus x minus 4 over x times square root 16 plus x plus 4. So that's the conjugate of the numerator, 16 plus x plus 4, right? So after you do that, the numerator is simplify the numerator. So this is 16 plus x, right? The square of the first term, minus square root of 4, which is 16, x times square root of 16 plus x plus 4. And so this is equal to, now you can see that 16 minus 16 is 0. You have an x on the numerator, right? So this is same as, now the x will be canceled. After we cancel x, you get 1 over root 16 plus x plus 4, right? Now if you plug in 0, you get 1 over 4 plus 4, which is 1 over 8, right? And let's see the third example we have here. Third example. And so we are looking for the derivative, I mean, the limit of such a function as x goes to infinity root x squared minus 2x minus x. Let's make it plus, right? And I can see that as x getting larger and larger, such a limit give you the horizontal asymptote of the function inside, right? So this kind of limit is very important to decide what does the graph of this function look like, right? To figure out the horizontal asymptote, you have to figure out what's the limit at infinity and negative infinity, right? So if you see that you have a difference of two terms, right? Both terms go to infinity. Now we know that infinity minus infinity is undetermined, right? So we have to do something to figure out the limit. The limit could be infinity, could be negative infinity, could be any finite number, right? Could be 0 also. Okay, how do we do that? And so one way to do that, we use the same trick, multiplied by the conjugate. So this is same as x goes to infinity, square root of x squared plus 2x minus x, square root of x squared plus 2x plus x, over square root of x squared plus 2x plus x, right? So why do we do that? We're good at fractions because we know that 1 over infinity is 0, right? We want to use that fact. So now if you try to simplify the numerator, so this is same as x goes to infinity, you get x squared plus 2x, square of the first term, minus x squared over square root of x squared plus 2x plus x, right? Simply try to cancel that x squared. What you have is the limit as x goes to infinity, you get 2x over square root of x squared plus 2x, then plus x, right? So what's the limit of this function? Now what you want to do is change it to a fraction, right? We just multiply by the 1 over x to the biggest power times 1 over x on the numerator. Also do the same thing on the denominator, right? That avoids changing the function here. So this is equal to as x goes to infinity, you have 2 over, do the distribution on the denominator, 1 plus 1 over x times root x squared plus 2x. Right, now we want to put our 1 over x into the square root. So this is as x goes to infinity, 2 over square root of 1 over x squared plus 2x, plus 1, right? So this is as x goes to infinity, 2 over root 1 plus 2 over x plus 1. I just distribute 1 over x into the parentheses, right? You get 1 over x squared times x is 1, 1 over x squared times 2x is 2 over x. Now as x goes to infinity, this term here goes to 0. All the other are finite numbers. So this is 2 over root 1 plus 1, so which is 1, right? So this is basically 3 examples on how do we evaluate limit at finite numbers at infinity, right? So we should know how to do it. Okay, now next we want to discuss a few examples on derivatives, right? And so more examples. Example. We want to find y prime, right? So the first one here is y equal to 4x plus x to 3 minus tangent of x to the power 100, right? That's the first one. You can see that not much tricks, right? We just apply chain rule. So chain rule here is you get y prime is bring down the exponent 100, keep the base, which is 4x plus inner function x cubed minus tangent of x to the power 100 minus 1, which is 99, and times 4x prime is 4, plus 3x squared, sum and difference, right, minus secant square of x. So that's how do we differentiate that first function. Now let's see another function, right? Sometimes we use chain rule, sometimes we use product rule, quotient rule. So make sure you know all the rules before you do the actual test, right? Second one, if you have y equal to cosine of x and to the power of natural log of x, right? How do we differentiate this function, right? This function is a very complicated function. Both base and exponent contains x. So this reminds you, maybe we want to bring the exponent down, right? So which means we want to use a method called logarithmic differentiation, right? And this is, we want to use a method logarithmic differentiation, right? So we take a natural log, you get natural log of y equal to natural log of cosine of x to the power natural log of x, right? And so natural log of y equal to natural log of x. So this is the reason we are taking the natural log, right? And now if you bring the exponent down, we can apply product rule and the chain rule on the right side, right, to differentiate that. So we want to apply the what's that called, the implicit differentiation, right? So the derivative of left side about x is chain rule 1 over y times dy over dx, which is same as y prime, equal to 1x times natural log of cosine of x product rule, right, plus natural log of x times 1 over cosine of x times negative sine of x. So again, here chain rule here, right? And so you get dy over dx is y times 1 over x times natural log of cosine of x plus natural log of x times negative sine of x over cosine of x, right? So this is how do we get y prime using the method called logarithmic differentiation. And now let's see one example on implicit differentiation, right? And also let's try to figure out a tangent line problem, right? So let's see one example here. And one more example. So let's see this. And number 3 here, we have our function sine of x plus cosine of y equal to sine of x times cosine of y, right? Figure out y prime. First one is find dy over dx, the derivative of y about x. Second one here is we want to find equations of tangent line to the curve, at the point which is 0, 1 power 2, right? If you plug in x is 0, y equal to power 2, that's clearly satisfied, right? Now Now, for sure, right, step one is very important. Let's try to do that. So again, here we are using the method called implicit differentiation. Right? So what do you do here is differentiate both sides about x. Somewhere you have to use chain rule. Just consider y as a function of x. Whenever you have y prime, just write down dy of dx or y prime, right? So if you differentiate left side, you get cosine of x plus negative sine of y, then times the duality of the inner function, which is y dy over dx, right? Equal to cosine of x production cosine of y plus sine of y, sine of x, right? Sine of x times negative sine of y times dy over dx, right? So this is basically the equation we obtain after differentiate both sides about x. Now, what we want to do next is move all the term contains x to one side, contains the duality to one side, all the other term to the right side, right? So you get this term here is negative, right? Move negative term to left side, you get positive, you get sine of x times sine of y and dy over dx, then minus sine of y dy over dx equal to cosine of x cosine of y minus cosine of x. So take out common factor, which is dy over dx, make a division by the coefficient, right? You get dy over dx is a big quotient, which is cosine of x, cosine of y minus cosine of x over sine of x, sine of y minus sine of y, right? So that's the duality of this function. So we know that the slope of the tangent line is the duality of at a point, is the value of the duality at the same point, right? So the slope of the tangent line to the curve at the point, which is 0, pi over 2, is, let's call that m, right? M is dy over dx, then plug in the point. The point is x equal to 0, y equal to pi over 2, right? So do that, you get cosine of 0, cosine of pi over 2, minus cosine of 0 over sine of 0, sine of pi over 2, minus sine of pi over 2, right? Now you can see that the first terms on the numerator and denominator are both 0, right? Second term are both 1. So this is negative 1 over negative 1. So this is 1, right? So that's that is the slope, right? So we get the equation. We can use the point slope form. Equation of the tangent line is y minus y value, which is pi over 2, equal to 1 times x minus x value, which is 0, x value at the point, right? So that is a equation of the tangent line. So y equal to x plus pi over 2. So that's basically the tangent line equation for tangent line equation we have, right? Using the slope and the point.